Okay, we're looking at section 3.6 in pre-calculus. We're looking at kind of taking some notes on critical points. So I want in front of you a piece of paper called Notes on Critical Points, and that's going to help a lot. And we're going to really just talk through what I want on this piece of paper. Okay, so we start with here. That's actually what we're going to do. So hopefully you got back your quiz and we talk about their plan for the week. All right, so we're looking at first, by the end of this section, we're going to be able to identify the end behavior of functions. We're going to find local minimums and local maximums of different functions. And then we're going to hopefully have some time to factor, or we might have to go into another video to do a reminder on factoring. Excuse me. So this is, I copied it from the book. So this is exactly what you see in the book. As far as the book definition, excuse me, of critical points. So what they're talking about is when you draw a tangent is a line that exactly touches a curve in exactly one point. And so the point where the tangent would be either 0, which is shown in these two, or would be non-existent, which is shown here, is one of these critical points. All right, so in the book definition, it is a point on the graph. All right, sorry, graph, I kind of misspoke there, where the tangent at that point is either 0 or it does not exist. Okay, so that's what we're looking at. Where a tangent is 0, it's undefined. So in your own words, what we're looking for is what's called a relative min or max, kind of where it's the lowest point and the highest point. And we're looking for a point of inflection. All right, so we're looking for, you might even want to put it's the lowest point in a while and the highest point. Maybe that's a little bit better in your own highest point, in your own words. So your own words is your own words. You can do what you can remember and help with. So the maximum, when we're looking at the maximum here, what I want you to draw is the maximum is just the highest point it could be, okay? The minimum, and this is really easy to show in parabolas, so I'm showing them in parabolas, is the lowest point it could be. Now, a point of inflection only happens in if you have a greater than 2. So there is no point of inflection in this graph or this graph. So a point of inflection only happens when you have a max and a min, and it could be more than one max, and you could have more than one point of inflection. We're going to show you that in a bit. So here, my point of inflection would be right here, okay? And it's always going to be halfway between, and this is my sign for between, the minimum and the maximum, your min and your max. Okay, your point of inflection is kind of that point here where, oh, it switches directions, all right? So it's the point where it switches directions. So it goes from going in the negative direction to a positive direction. Switch directions. There is what I was talking about, okay? And so this is again what the book is. So they have some things here we're going to talk about is this relative maximum and absolute maximum. So we have these graphs, and you could say, well, right here I have a maximum right there, but really the graph goes higher right here. So truly it's not an absolute maximum. It's what's called a relative maximum or a local maximum. So kind of like in this general area right here, that's the maximum. All right, same thing right here. In this general area, that's the minimum, although we know it goes down even further than that. Okay, so relative is known as a local, I can't spell today, local area. And absolute is the absolute is definitely either the highest or the lowest it can go. Option. Oftentimes the absolute in ours often are infinity. Okay, it goes on forever into infinity. And we saw that a lot when we were looking at chapter 1, where we said we went to positive infinity or negative infinity. So a lot of times that absolute is infinity. So let's look here. We have two dots, and we want to know the maximum and the minimum. And we're looking for points. So points are given as an x and a y. So the maximum, and it's a local max. So we're going to use the word max, and we're going to just assume that you know we're talking about local maximums and local minimums, because we know that most likely it's going to be infinity in the numerator, or, into positive infinity in one direction and positive negative infinity in the other direction. So for our local max, this is our maximum because it's kind of the highest point, or kind of when we have a curve that curves us up to the top and then kind of comes back down. So that's at the point 0, 1, and that's this point right here. And this is the point 1, 0 right here at the other one, and that's our min. All right, and then the point of inflection would be the point halfway between these two, and I know it's kind of hard for me to show that, but one way I do is I would add my two x's together and divide by 2, and so here I'd be at 1/2. So it's 1/2. So what I'm going to do is to decide 1/2 comma what, sorry about that, we had like a little glitch, 1/2 comma what, I would actually look at my graph and say, okay, where am I at a half? And it looks to me like there I'm up at a half. And so that's where I got the other half. I kind of did a visual check here. A lot of times we're going to have an equation to go along with it. And so the point of inflection, you're just going to plug in the halfway x to figure out your equation. In our next equation, our maximum would be right here, and it looks like here we're at 3, 3. So that's going to be our relative maximum, and the maximum we're dealing with. Looks like our minimum is -1, -3. Okay, point of inflection. So we need to look at halfway in between these 2 points. So I'd be at 3, plus -1 divided by 2. All right, so that's what we're looking at here. So we actually have 2 divided by 2. I turn out with 1. So we know the x in our point of inflection is 1. I'd see at the graph, where am I at 1? It looks to me like I'm at 1, -1, and that's my point of inflection. So that's kind of the halfway in between the highest point and the lowest point, okay? It's not always the average of your y's, but it always is the average of your x's, okay? Because it really depends on the graph on whether it's the average of the y's as well. Sometimes that works, sometimes they don't. So like this is kind of an interesting curve right here. A little harder curve that we're looking at, but let's look and see if we can identify our really important points. There's our minimum, there's our maximum. So our max, when I count over, I'm going -6 to the left and then 4 up. So I can kind of see that. Our minimum, when we look at it, it looks to be at -2, -3. Okay, now there's going to be times where we're going to be given these two numbers and we're going to have to decide which is the min and which is the max. And what it's really based on is what the y is. The higher y is going to be the maximum and the lower y is going to be your minimum. So really kind of logically, hopefully that makes sense. Later on, when you don't have the graph, you're going to start with just the values. It's a little harder to check. Point of inflection. So we have to find our x value first for our point of inflection. So we're going to look at our x value and our maximum, our x value and our minimum. We're going to divide it by 2. So it turns out to be -8 divided by 2. So our x value is -4. And in this case, we're just going to look at the graph and do our best guess as far as where it is. 1, 2, 3, 4. And again, it's going to be our best guess. So I'm going to say that looks to me to be about -3.8. At this point, I'm okay with just a guess. 3.75 would have been fine. We know it's not quite over to -4, -4. So we're just going on a graph here, so it's our best guess. Later on, we're going to have graphing calculators, which we can get much more accurate. Love number 2, because it shows us that you can have more than one maximum. And again, these are relative maximums. So kind of in an area. A maximum is where you kind of change direction. We're going up here, and then we come back down our slope here. And then we go back up, and then again back down. So where there's a kind of a change in direction is technically our a critical point right there. Is really what we're looking at, is a change in direction. So we are going to have 2 points of inflection as well. We'll deal with that in a minute. So my first maximum is here at 2, 3. Oh, and I messed up notice how we have kind of different things at the bottom. It's at -1, 3. So we kind of have to watch our markings at the bottom. The second maximum is at 1.5, 2. Okay. Now, minimum. Well, that's easy. There's just the one, and it's at 0.5, 0.5, a half. Again, this is a 0.5 and not quite 1. All right. So now we need to figure out what's that inflection point that is somewhere here in between in this area. All right, so that's what we have to figure out first, is what's our inflection point that's in between our first max and our minimum. So we're going to go -1 plus 0.5, and we're dividing it by 2. And so you actually end up to have 0.5 divided by 2, which is 0.25. Okay, so our first point of inflection, sorry. So we're at 0.25, and we kind of have to decide visually where are we. All right, so at 0.25, I'm going to call it at 1. All right, now we need the other one. So now we're between 0.5 and 1.5. All right, and we want to divide that by 2. So technically we're actually going 2 divided by 2, which is 1. So we're at 1, comma, I'd say we're here. So we're at 1, comma, 1.5. So these are both my points of inflection here. All right, so it's okay to have 2 points of inflection when you have 2 minimums or 2 maximums. Our last one, if you notice, we only have a maximum. We don't have a minimum. So our maximum is at -4, 1. There's no minimum. There's no point of inflection. So if there's no min and a max, there's not going to be a point of inflection. And so I like that we kind of covered one of those as well. So now let's look on the back side. So in this one I said, okay, I want you to use now your graphing calculator. So let's talk about how you use your graphing calculators to do this. We're going to be using the y equals. So I have y equals there highlighted. And we need to enter in 3x to the third. So we're going to go 3. And this is the hardest part, is where do you find this x? And right now it's in red on the screen. So it's under the word link. It's kind of under the word mode or the mode key. So there's my 3x. To the third, I'm going to use my caret here to say to the third. And then I have to hit my over arrow. So that's all I wanted, not like 34th. And then -9, and I have to hit x again there for -9x, and -5. Okay, so I put in my y equals, I want that graphed. So I'm going to click on the graph key now. And we can look and see where it graphs. And see how right here, I don't know if I can write on this, I don't think I can. We kind of go up here and down, and it comes back up. I love it. It kind of really shows us where our points are. Now it's asking what's happening at that point, -1, 1. And is it a max or is it a min, is really what we're talking about. Or do you think it's a point of inflection? Well, I can look at this graph really carefully and say, oh, really easily, and say, oh, that one's going to be a max. All right, so our answer to number 4 is it's going to be a max. Now let's go into how do we put in number 5. And then number 5, I'm going to show you even a better way that we can kind of look at this. I'm going to go back to my y equals. All right, I'm going to clear this. So I hit clear to clear it all. And now I'm going to put in x squared. So I have x, and the quick way to do x squared is just to use that square button right there, and it squares it for you. X squared plus 5x, so plus 5x, all right, minus 6, and that's my equation. I'm going to graph it just to kind of look and see how does it look. And we're looking at the point 2.5 and 12.75. Well, it's not on our graph, all right? So there's one thing we could do is we can look at our window, all right? And we can make it a bigger window. So we need to get all the way, I need my y's to get all the way to 12.75. So instead of from -10 to 10, there's one thing here we could do. We can go from -15 to +15. And we can see, like, we're basically making our graph a little bit bigger. So it's like I want to see a different window here. So now I'm looking at my different window, and now I get a better idea. And it still really goes at 2.5, it goes up to 12.75. It's even higher. I would have thought I would have seen that. But I'm not, but I can still tell it's not going to, oh, is it a point of inflection? I think I might have it be a point of inflection. Let me show you something else here. One of the things I can do here is my zoom. I can zoom out like I want to see again. So I can just say on 0, 0, I'm going to zoom out. And it says on 0, 0. Yep, and I just want to zoom out here. And it really is going to give me a better idea of how high that goes. Oh, I might need to zoom out again. So it really goes up high.